We'll take a look at expanding logarithms. First, the product property. So we have log base b of two things getting multiplied together, m times n. But we can expand this into two logarithms, log base b of m plus log base b of n. Here we have Clifford and a smiley face getting multiplied together. So log base b of the product of Clifford times a smiley face is log base b of Clifford plus log base b of a smiley face. And this really is not a surprise. We know when we have the same base and multiply, we add the exponents. And the output of a logarithm is an exponent. So here is an example of how and why it kind of works. We know that log base 3 of 81 is 4 because 3 to the 4th power is 81. That's the question. When log 381 asks what power of 3 gets us to 81, and it's 4. Well, what if we have 27 times 3, which is 81, in those parentheses instead of 81? Let's bust out that new product rule and see what happens. We can expand with log base 3 27 plus log base 3 of 3. Well, log base 3 of 27, that's 3. 3 to the 3rd power is 27, and 3 to the 1st power is 3. So this turns into a 3, this turns into a 1, and 3 plus 1 is 4. The same answer. So it does work, and that's kind of why it works. Next, the power property of logarithms. Here we have log base b of u to the n power. Well, we can take that n and move it to the front of the logarithm to multiply and make it a coefficient. Now it's n times log base b of u. Check this out again. It's in the exponent or power position right here, and then we move it to the front. And now it's n times log base b of u. This is how come it works. If I have log base 4 of x times x times x, that's x to the 3rd, but we're writing it as x times x times x. Well, we can expand that with the product rule into log base 4 of x plus log base 4 of x plus another log base 4 of x. There's 3 log base 4s of x's. With the power rule, log base 4 of x to the 3rd power, we can take this 3 and move it to the front. It's a shortcut, and it works. We get the same answer. Let's take a look at expanding some logarithms with multiple factors then. We want to expand it so that every term has a single logarithm and there are no exponents involved. So here we have log base 5 of the product of x to the 3rd y squared. The first thing we're going to do is use that product rule to expand the logarithm and split these up. So now the x to the 3rd is over here, the y squared is here. Log base 5 for both of those. Now we can use our power property and move this 3 to the front of that logarithm and the 2 to the front of this logarithm. And we're done. We've got single logarithms for each term, and there are no exponents anymore. Pause the video while you try this one. Expand log base 7 of m to the 5th, n to the 3rd. And hopefully there's the answer you got. 5 log base 7 of m plus 3 log base 7 of n. Check this one out. We have log base 9 of the square root of x to the 6th y to the 3rd. Well, we don't really want to have any radicals here with these logarithms. It's better to have exponents. So let's turn this radical into an exponent. A square root is the 1/2 power. Now we got a couple of ways we can go here. This first way, I'm going to use power to a power and realize that x to the 6th to the 1/2, well, we multiply those exponents, and y to the 3rd to the 1/2, we'll multiply those exponents. And so 6 times 1/2 is 3, 3 times 1/2 is 3/2. Then we can use that product rule to expand the logarithms and add them because we were multiplying those factors. So now it's log base 9 x to the 3rd and log base 9 of y to the 3/2 power. And our last step now is we can move these powers in front. That 3 exponent can come to the front. This 3/2 can come to the front. And there's the result we get. You may have thought, though, a few steps ago, back when this 1/2 power was sitting out here, you may have wondered, well, how come we could move this 1/2 to the front? Why didn't we do that? Well, we can. That's another way to attack this problem. So if you choose to move the 1/2 to the front, now it's a coefficient, and it's 1/2 log base 9 of all of x to the 6th y to the 3rd. When we split this up, that 1/2 goes in front of both of them. It's kind of like the distributive property. So remember, the 1/2 would have to go in front of both of these terms. And then now we'll wrap it up by moving this exponent to the front. 6 times 1/2 is 3. 3 times 1/2 is 3/2. And we get the same answer we got the other way. Doesn't matter which way you do it. It all works. The division property of logarithms. Similar to the product property, except now we subtract instead of adding. And that's really not a surprise because when we have the same bases and divide, we subtract the exponents. So this m over n will take log base b of m minus log base b of n. When we have log base b of Clifford over a smiley face, it's log base b of Clifford minus log base b of a smiley face. So let's look at how this would work. Here's log base 5 of the fraction x to the 3rd over y squared. Well, that means we're going to subtract. So we now have log base 5 x to the 3rd minus log base 5 y squared. Whatever was in the denominator is getting subtracted. Kind of not a surprise because remember, if you're in the denominator, that means you have a negative exponent. And here is a negative sign. Subtracting is adding the opposite, or adding a negative. Now we can move these powers or exponents into the front. This 3 will come to the front to be a coefficient. This 2 will come to the front. And now we have these single logarithms and no exponents. Go ahead and pause the video while you try this one. And hopefully that's what you got. 5 log base 2 of m minus 7 log base 2 of n. Now we can use these properties with some numeric ideas. So to 2 decimal places, here's what log base 10 of 5, log base 10 of 4, and log base 10 of 3 are. It makes sense because log base 10 of 1 is 0, because 10 to the 0 power is 1. And log base 10 of 10 is 1, because 10 to the 1st power is 10. So you would expect log base 10 of any number between 1 and 10 to be between 0 and 1. That's what we've got. Well, we want to find log base 10 of 36. I have no idea what that is. I know it's between 1 and 2 because log base 10 of 10 is 1 and log base 10 of 100 is 2 because 10 squared is 100. So I know it's between 1 and 2, but I don't really know what it is. However, I do know that I can get 36 by multiplying some of these values together. 3 times 3 times 4 is 36. So I can write this as a product. Well, we've learned that we can now expand that. So now it's log base 10 of 3 plus log base 10 of 3 plus log base 10 of 4. And up here I found out what these values are. So I'll substitute them in and add them up to get 1.56. You try this one. Log base 10 of 60. Using these facts up here, there's enough information for you to find log base 10 of 60. And hopefully this is what you got, 1.78. Did you notice that 5 times 4 is 20 times 3 is 60?